Okay. I'm just going to do a really short lesson here on Cramer's rule and reduced row echelon form. The first thing I want to start out with is Cramer's rule. It's using determinants to solve a system of linear equations. So the whole point and purpose of this is to find the x and the y that makes that set of equations true, solving a system of equations. So Cramer's rule is the most efficient way to solve a system of equation by hand. The only thing you need to do is to evaluate 3 different determinants. You do have to memorize the rule as well. And here's Cramer's rule. You first start with the coefficient matrix. 2x plus 6y has coefficients of 2 and 6. 2x plus 3y has coefficients of 2 and 3. Find the determinant of that, which is the diagonals product, 2 times 3, 2 times 6, and then subtract them. So negative 6 is the coefficient matrix determinant. Now, to find x, what you do is you replace the answers, 16 and 7 in this case, in for the x coefficients. 16 and 7 in for the x coefficients. Leave the 6 and the 3. Leave the y coefficients. Do the determinant. That's 48 minus 42, which is 6. Now, this isn't done yet, because the x value that makes that equation true is not just 6. We had to find the coefficient matrix determinant first, because what we're going to do is we're going to take the determinant of the x coefficient matrix and divide it by the determinant of the coefficients. So, dx divided by d of the coefficients is negative 6 divided 6, which is negative 1. Now to find y. Basically the same process. The determinant of the y matrix, we're going to take the original coefficients, leave the x's, put the answers, 16 and 7, in for the y's. Scroll that back up real quick. I left the x's, put the 16 and the 7 in for the y's. Evaluate your determinant. 14 minus 32, which is negative 18. Now, dy divided by dc, negative 18 divided by the original negative 6, we're going to end up with 3. So my ordered pair, negative 1, 3. Just saving myself some space here. Okay. Now, scoot it over to the other side. Try to do this in just a few minutes. I'm going to do a reduced row echelon. Same problem. So I'm going to set the matrix up now as a 2 by 3. That is every piece, x coefficients, y coefficients. We sometimes put a dot between those, and then put the answers, 16 and 7. So we're going to set that up in just a regular matrix form. Now we're going to do our row operations, and you've already had the lesson on this. So you can divide or multiply any row. You can add and subtract the columns. Those are the 2 operations that are legal. So I'm going to start, I want a 1 in this spot. So I'm going to divide the top row by 2. Gives me a 1, a 3, and an 8. And replace my new top row with 1, 3, and 8. Notice, second row, I'm going to leave alone. Now, I want a 0 in this spot. So I'm going to multiply the top row by negative 2. Negative 2, negative 6, and 16. And then I'm going to simply add that to row 2. And why would I do something foolish like that? So that I could get a 0 in the first spot. Negative 2 and positive 2 is 0. Now, I still have to add all these together, just like normally with elimination. Negative 3 and, what is that, 9? Neg 9. Okay, so same top row. Don't change that. This 0, negative 3, negative 9. The sum of row 2 times row 1 times negative 2 plus row 2 puts a 0 in that corner. Now, row echelon has a 1 in the diagonals, a 0 in the corner. So I need a 1 here. Easy to do, just divide by negative 3. So that gives me 0. 0 divided by negative 3, 0. Negative 3 divided by negative 3, 1. Negative 9 divided by negative 3, 3. So now, finally, we have we have row echelon form. Now we could go one more step and put it in reduced row. And I'm going to do that for this example so that you can clearly see how this matches up with this. Now that last step, I want a 0 in this spot. Reduced row means I have 1 in the diagonal, 0s above and below those 1s. So I'm going to take the bottom row times, well actually, to get reduced row, I'm just going to erase that, because if I just take row 1, 1, 3, and 8, and add to that the 0, the neg 3, and the neg 9, I'm going to get 1, 0, neg 1. New top row. 1, 0, neg 1. And then divide that one by negative 3 again. So you have a 1 in the diagonals, a 0 everywhere else. And I'd already shown that step, so I didn't re-show it. But it's basically dividing this bottom row by negative 3. And now we have it in reduced row. Now note, I'm going to use a highlighter, these two numbers. 1x, there's no y in this anymore, so x equals negative 1. No x here, just 1y equals 3. So x equals negative 1, y equals 3, which is exactly what we got here. Just as using row echelon, this is using determinants in Cramer's rule. As you can see, this is a lot easier and less time consuming. But they both work. So that's just a little reteach. I'm going to upload that onto YouTube so that you guys can check it out if you have any lingering questions on determinants.